This is a statement that a lot of people think is true. People would guess that it's true or make it up. We start doing double formula work, so then people just make this up. And it looks like something, I guess, that might be true. I'm not sure what operation it is or why it is or how that works, but it just seems to be people's intuition that this is true. But when you look at that, like, how can you make sense of what it's saying? Think about that statement. And do you think those are the same thing? They would be equal? Okay, good. Why? So just your understanding of what the sine function is, to you that you think that doesn't make sense. Very good. What? Anybody else? If this were true, it would be called an identity. If it were true, it would be true for all values of theta. It would be an identity. And another way to think about identities that you haven't thought about before is the graph of each side. So let's think about this. What if I do y equals sine of 2x and y equals 2 sine of x? Right? Those would be two graphs. If it was a true identity, if it was true that they were equal, what would be true of their graphs? They'd be the same graph. Do you think those are the same graph? Why not? John, why not? So one is a change in amplitude. And so if this is 1 and this is 2, -1 and -2, it's going to go up bigger, up to 2 and down to 2, right? So this one is a change in amplitude. And this one is a actual horizontal compression, because we're multiplying by 2, so it'd be a horizontal compression. I made my graph too small, of course. And so it's going to go, and it's only going to go halfway, something like that. Those are not the same graph. That's for sine. For cosine, you could do the same demonstration. Those are definitely not the same. This is not true. So please don't do that. Don't simplify what we're going to do today and make up your own idea that sine of 2 theta is the same as 2 sine theta. I could just pull the 2 right out. Here would be, if you did that, just because it worked with 2 wouldn't mean it would work with other numbers, but that's probably what people would assume. So that would also mean that something like sine of pi over 4 is the same as sine. We don't think about it this way, but it's like 1 over 4 times pi. So is that the same as 1 over 4 times the sine of pi? No. What is the sine of pi? From the graph? 0. So I could factor out any number, I'll multiply by 0 every time, and you'd get like you'd get every answer to be 0 if you tried to do it. Like, it doesn't make any sense. That's not how it works. This is not true. You can't take part of your angle and somehow pull it out side to the front. Like, that's not a thing. So anyway, so it doesn't work for any numbers. It's not how it works. It's a little bit more complicated, but it's not too bad. So what I want you to try is, and here's your hint, using the compound angle formulas, we're going to determine formulas for sine 2 theta, cos 2 theta, and tan 2 theta. Okay, so go. First step is the hardest. about how you can relate that to the compound angle? Some interesting ideas, some people trying things, that's good. How many people feel stuck? Nobody? You don't have to put your hand up to this question because I understand that you might feel kind of embarrassed admitting it, but how many people feel like this is too hard, so I'm not really trying? Like if that's, like think to yourself, is that what's really going, like, I don't think I'll ever be able to get this, I'll just wait. It is hard to come up with new ideas, it is hard, but I think even if you don't get there, so I'm gonna help you out here. If you didn't get there on your own, next time try harder. Try to come up with something, even if you come up with something that's wrong, that's like still good practice towards problem solving, believe it or not, I think. So, you know, try never to sit there and do nothing and tell yourself, well, I'm not going to get this. I'm never, like, try to get rid of that thought in your head. So Jason, what did you think might work here?
Well, I figured 2 theta is the same as theta plus theta.
Okay, stop right there. Ah! That makes sense. Okay, now keep going. Yeah, no, not you. Everybody. Now that Jason gave us the first step, I bet you got the rest already.
I think so.
Good job. I bet you, so now everybody can probably take that and do the next couple steps and do it for cosine and do it for tan. So give that a try. You could, but now you still have sine 2 theta, and we don't know what that is. That's an interesting idea, though. And yeah, that kind of thinking would work in some other cases for some other questions. Just using the formula for sine, that's what I get. And what does that simplify to?
2 cos theta sine theta.
Those are both the same, right? Sine times cos is the same as cos times sine. When the angle's the same, it's theta, right? Usually it's AB, but so this is 2 sine theta, cos theta. Very nice. If you haven't done this one, you give it a try. Formula would usually be cos A, cos B, but A and B are both theta. So it's just cos theta, and then change the sign, sine theta, sine theta. So order matters here because of that subtraction. And what is cos theta, cos theta? What's another way of writing that? Yeah, that's cos squared theta. Now be mindful when you're working, if your handwriting is not the best, cos 2 theta and cos squared theta may look very similar on your page. And it is not my job to have to struggle to determine what you mean or to guess what you mean or assume you meant the correct thing. It's your job to communicate. So make sure that you write those things carefully. This is a for you class. The way we present our answers is a big deal. Okay. Okay, and then same thing on this side. So minus sine squared theta, and then it's important to notice or to note that because I have squareds in here, I can rearrange this a little bit, and in some cases I may want to do that. So how could I use the Pythagorean identity to rearrange this but preserve the left side and the right side? What could I replace cos squared with? Close. 1 minus, good. So 1 minus sine squared theta minus sine squared theta, which gives me 1 minus 2 sine squared theta. Or I could replace sine squared theta. And I would get cos squared theta minus bracket 1 minus cos squared theta, which is, so that's going to be a negative 1 and a positive cos squared theta. So it's going to be 2 cos squared theta minus 1. So you do kind of need to, you do need to know all three. There's one, there's the other, there's the other. Three different, and if we're using them in identities, all three are ones you can use directly, and they, in some cases you need to use one or you need to use the other, or what have you. Okay, and then tan. Again, if you haven't done tan, go ahead and try. Who can help me out with the next line? Who remembers the formula for tan? Very nice. And then this can be simplified. Tan theta plus tan theta, that's like x plus x, 2x. So 2 tan theta. And tan times tan, that's like x times x, that's x squared, right? So 1 minus tan squared theta. So the nice thing is this, the double angle formula for tan is a lot like the compound angle formula for tan. They're very closely related, so you know there's not a lot of extra memory work there. And then, but these ones are different in important ways, so you got to memorize them and not get them mixed up with the compound angle. There's a lot of those. There's a lot of these. There's a lot of new formulas. Okay. Okay. Any questions before we start on one kind of question here? Any questions? Any questions? Any questions? I'll be honest with you, this is one of those math class questions, just kind of made up, like, to get us working with these formulae. But there's some good thinking, some good review of some previous stuff that we did. But it's not maybe intuitive, so you probably want to have seen it once before you go and try to do it yourself. So sine theta is negative 2 over 5, where pi is less than theta is less than 3 pi by 2. Find cos 2 theta and sine 2 theta. And usually tan 2 theta as well, but that's not on here, so I don't know. So we have to understand what information we're being given and sort of what the context is telling us, and then we just use the formulas to figure out those answers. When it says sine theta is negative 2 over 5, what's that telling us? What information does that give? It gives us a lot of information. Negative third or. If it's negative, it's the third quadrant or the fourth. But it can only be the third because. Yeah, because of the domain that it tells us to answer on, right? But if this wasn't here, if we just look at the sign part, the fact that it's negative third or fourth quadrant, okay? But normally we're only looking at one quadrant. We're only interested in one quadrant. So this does tell us, hey, we're in quadrant 3. Very good. What else does sine tell us in this case? If I have to find cos as well, I want to take sine and circixertix, break it up into what's the y component, what's the r component, and then we're going to figure out x. Okay? So y is going to be, remember doing this? We talked about this a little bit, Ayla? Thank you, negative 2, because we're in the bottom quadrants where sine is negative. So y is negative in the bottom quadrants. I mean, that is the connection there. And so negative 2, we want to make sure we keep it negative. R is my 5. And then x, how am I going to find that? Pythagorean theorem. So it's going to be the square root of 5 squared minus negative 2 all squared. So that's 25 minus 4, the square root of 21. So x is the square root of 21. We did questions like these on the very first day of this course when we reviewed grade 11, and you're given a point, and you start talking about the point and the radial arm, that kind of thing.
So since we have like an equation for cos 2 theta that has sine in it,
Yes. Okay, so we've got these. Let's get to it. John, to give you a better answer, like in this case, could you get away without it? Maybe, but this is how you solve these problems. Which, that's what you were actually asking, right? In this case, do you actually need to? Possibly not. What's the formula for 2 sine theta? Sine 2 theta, sorry. John, what's the formula for sine 2 theta?
sine 2 theta is 2 sine theta cos theta.
So we need the cos theta. Yeah, we do. Okay. The other thing is, do we have to do all of this in this question? Maybe not, but often a good way to take the next step, thank you, that's perfect, is we already know sine theta. I'm just going to write it down again. You wouldn't have to rewrite it, but. And then what is cos theta? In the third. Not negative. Good, thank you. So that's something we missed, and I should add it back. Because we're in the third quadrant, we should have, we'll just call this negative. When you take square root, it's plus or minus. But we know that it's going to be negative because we know what quadrant we're in, so we don't have to worry about both cases. We just say, oh, x is negative because we're in quadrant 3. So we make that statement, okay? So this is negative root 21 over 5, and then tan, which again we don't need, but I still think it's a good idea to do this. So Sir Kixer ticks, tan is y over x, and third quadrant tan's positive, it's negative over negative, so that makes sense. So y over x is 2 over root 21. So it's kind of like listing your givens almost here, right? So I've got those written down. I'm going to use them. Cos 2 theta, in this case, we have 3 choices. It doesn't matter which one we use. Cos 2 theta, cos squared theta, sorry, minus sine squared theta. Let's do this one. So that is negative root 21 over 5 all squared, and then negative 2 over 5 all squared. Just using the values of sine theta and cos theta and plugging them into our formula. Everybody okay with that? Understand what we did there? And then we evaluate. So the negative's gone. Root 21 squared is 21. And 5 squared is 25. And then this negative's gone again. So 4 over 25. 21 minus 4 is 17 over 25. You don't have to write this down. What if instead I just chose to use a different formula? So we've got 3. Let's use the 1 minus 2 sine squared theta. 1 minus 2 sine squared theta is the negative 2 over 5. So negative 2 over 5 all squared, which is 1 minus 2 times 4 over 5. So, sorry, 25, which is 1 minus 8 over 25, which is 25 over 25 minus 8 over 25, which is 17 over 25. Same answer. And you can do the same for the other form. You better get the same thing, obviously, right? But math works out both ways. Okay, and then we were asked to do sine 2 theta as well. So sine 2 theta is 2 sine theta cos theta. 2 times sine theta is negative 2 over 5 times cos theta, which was negative root 21 over 5. So that's 2 times 2 is 4. So 4 root 21 over 25. Any questions? Yep. For now, let's not worry about it. Well, in some cases, we might want to do that. It kind of depends on what we're doing. In some cases, we might want to do that because we might be able to simplify it further. For example, if it divided with 25, you could simplify it a lot further. If we were going to do something with that answer, 100% absolutely we would use the simplest form. I don't think it's going to come up, so for now, don't worry too much about it. But in general, we usually would do that. I want to see the steps though, because I have even noticed, even on the quiz yesterday, I think some people are using their calculator to get answers, and they don't really understand the answers of the calculator. So for example, when I evaluate sine of pi by 4 on my calculator, it gives me this. which is the simplified version, right, of 1 over root 2. So when I see that, I ask the question, does this person just using their calculator, and are they doing it to speed things up, or are they doing it because they don't know how to do it otherwise, or that kind of thing? So this way, like showing all the steps is important, whether if you reduce it in the end, that's great. Don't skip the steps to get there though, right? Does that make sense? Kind of? So that I can see that you understand the math yourself. Yeah. This is going back to something that from grade 11. And so I'm not going to reteach the whole thing, but we used this, Sir Kixer Tix. The point of Sir Kixer Tix is that it's taking SOHCAHTOA and putting it on the Cartesian plane, and opposite is like the y, and adjacent is like the x. So when I'm given sine of negative 2 over 5, I know that it's opposite over hypotenuse, or y over r. I can break it up into those components. I can find x, and then come up with statements for sine, cosine, and tan, because I need x for that. But basically, it came from Sir Kixer Tix. Does that make sense? And Pythagorean theorem is because it's a right triangle. Okay, let's do another question here. One more. What's different about this question? From ones you've seen in the past. Yeah, all the compound angle questions were pi by 12s. Good? And then before that, they were all pi by 3s, pi by 4s, pi by 6s. We've never done a pi by 8. So the nice thing about double angles is it does give us, it adds on to what we can find the exact value of. The important first connection that we have to make is that, I'm going to do this off to the side. What is 2 times 3 pi by 8? The way that we're going to find the exact value of sine of 3 pi by 8 is quite different from how we use compound angle formulas and that kind of thing. Like it is quite different. So we need this important first step. What is this equal to?
6 pi by 8.
Yes. And what else? What if you reduce 6 pi by 8?
3 pi by 4.
3 pi by 4. And so I could get that by recognizing that I can divide 2 out of both of those, right? The 2 cancels or divides 2 from the 8 to 1, and I get 4. And I can find the exact value of this. So that's like, if this is my theta is 3 pi by 8, 2 theta is 3 pi by 4. Does that make sense? If theta is 3 pi by 8, 2 times theta is 3 pi by 4. Yeah? Okay. What is the formula for sine 2 theta? Who's got that? Yep.
2 sine theta cos theta.
So sine 2 theta is 2 sine theta cos theta. Okay. I'm going to let you take what we've done here and our formula. Think about that for a moment. Okay? Oh, actually, I'm going to give you a bit of a better hint. I also want you to think about this relationship. So cos 2 theta, and there's 3 versions of it, but think about this one. Okay. Think about that for a minute. Think about what, because this is tricky, but it's a good mental exercise, like what we've done before. Okay, let me see if I can help you out a little bit further. If I take the value that we're looking for, my theta over here, and I sub it in, I'm going to sub it into this first one. I'm going to sub it in on both sides. I get cos of 2 times theta, which is my 3 pi by 8, is equal to 1 minus 2 sine squared theta, which is 3 pi by 8, right? That's the theta. What is 2 times 3 pi by 8? 3 pi by 4, that's what we already talked about. What is cos of 3 pi by 4? Negative 1 over root 2. What can I do now? Does anybody see it? How does this, we're supposed to be finding the exact value of the sine of 3 pi by 8. Layla? How is that going to help us? Multiply it where? What do you mean? Not quite. Also, you can't do 1 minus 2 because of BEDMAS, right? Because that's 2 times sine. You can't subtract those, but... Yep. Could move the 1 over. Nice. So let's start doing that. Negative 1 over root 2 minus 1 equals negative 2 sine squared 3 pi over 8. And then what am I going to do next? Megan, what do you think? I could, yeah. Like, I think you're on the right track. You have the right idea. So what would, like, we're going to keep going, right? You keep moving everything to the other side. So let's divide both sides by negative 2. Do you want to do that? What happened here? Is that just the way it looks, or is something screwed up? Ooh, I'll fix it. Negative 1 over square root of 2. So this is going to be negative, I'm going to do this the slow way, over negative 2 equals sine squared of 3 pi over 8. Okay, and then I can factor out a negative 1 on top. So negative bracket 1 over root 2 plus 1 bracket all over negative 2. And those negatives will cancel each other, like Megan said. I think that's what you were getting at. And then what am I going to do? My last step is take the square root of both sides. because that's what the sine squared, that's how I'm going to undo that. So then I'm going to take the square root of all of this is equal to sine of 3 pi by 8. And just to simplify, and I'm going to write it the other way, sine of 3 pi by 8 is equal to the square root of 1 over root 2. And I'm going to simplify this a little bit further because we don't want fractions in fractions, plus root 2 over root 2 all over 2, which is equal to the square root of 1 plus root 2 over root 2 all over 2. You don't have to do it in this order. You don't have to do it in this many steps as well, but I just want to show you carefully. And then this is going to be 1 plus root 2 over 2 root 2. And that's what my final answer should look like. Shouldn't have fractions in fractions. That is something that we simplify, like we talked about yesterday with tan. Any questions? So you end up getting a bit of a mess of an answer, but that's as good as we're going to get in terms of our exact value right now. And when we take the square root, we're thinking positive or negative, right? But when we're doing exact value, we're thinking about like quadrants and that kind of thing. And so we know that this is a quadrant 1 angle, so it would be positive. So you need to think about like positives and negatives, but when we're taking a square root, it's not just plus minus. Like we can figure out which one it is. Thinking about quadrants, does that make sense?